Hi, we welcome you to our podcast, On Stage with Enterprise Thought Leaders. I am Tejdeep Desai, Technology Editor at On.media's B2B Technology Publications. Today we are diving into the 2025 Open Source Security and Risk Analysis Report findings with our guest, Mike McGuire. Mike is a Senior Software Solution Manager at BlackDuck. He focuses on open source risk and software supply chain security. With his background in software engineering and product strategy, he helps organizations navigate the complexities of application security. Mike, is there anything that I might have missed and you would like to add to it?
No, I think that pretty much covers it. I appreciate you for having me on. It's about my fifth year working in application security now, and that means fifth year talking to folks just like yourself about the state of open source software usage in the commercial world and some sort of the risks that it could introduce into the code unmanaged. So thanks for having me to talk about it today.
Okay. So welcome to the podcast.
Thank you.
Okay. So, Mike, let's start with the big picture. Like the report states that 97% of analyzed code bases contain open source components. So this shows that the open source adoption is nearly universal. But with the rising complexity in code bases, how should developers approach managing transitive dependencies and effectively?
Sure. So the first thing I'd have to recommend is using dependency discovery and tracking tools, right? Because automation is going to be key given the prevalence of open source software usage in modern application development, which you just noted. So this is going to help teams use minimal and well-maintained libraries, which is another recommendation that I would say. If we get a little bit more tactical, there are a few standard tasks and best practices that development teams can use to manage dependencies. First of all is lock your dependencies. So this helps teams define exact versions so they can prevent accidental upgrades, which can, of course, introduce new transitive dependencies. The next recommendation I'd say is to keep dependencies updated on a regular cadence or a regular basis. Now, for this, automation is absolutely key as well. So it's important to test the updates in a staging environment, though, right? You don't want another CrowdStrike where a mail-contested update is pushed out to a production type environment, and then obviously we see every dependent application sort of melt down. But otherwise, package managers can be used outside of automation to check outdated components. So if you just do something like an npm outdated command in a command line, then npm will provide the list of outdated components that you could update from there. I'd say finding and removing unused dependencies is important as well. You could use package managers to do that also. So if I use the npm example again, if you use npm prune, this removes dependencies that are not listed in a package.json file, which means they're no longer referenced in a project. And finally, you should always just treat transitive dependencies just like you would treat a direct dependency. So scan them for vulnerabilities, identify the licenses associated with them, and evaluate them for conflicts with direct or project licenses. And of course, integrate policies into your CI/CD pipelines so that you can break builds or trigger certain workflows based on policy violations or based on the findings.
Right. So, Mike, this brings us to another major concern. So, with 86% of assessed code bases containing vulnerabilities, what are the most effective strategies developers can use to mitigate security risks in open source software?
Sure. So this usually requires a pretty nuanced conversation. We could probably do an entire podcast episode just on this alone. But if I break it down into the simplest terms, step one would be establish visibility. So only 77% of dependencies that we found in this report we're discussing were found via regular package manager inspection, which means that only 77% were intended to be in that project or broader package manager. And then 70% of the dependencies were considered transitive. So this makes visibility very difficult to get, but you do have to establish complete visibility before you can start getting your arms around associated vulnerabilities. Now, the next challenge, once you have visibility and once you identify vulnerabilities, the next challenge is prioritization of fixing those vulnerabilities. So 81% of code bases that we analyze contained high risk vulnerabilities, and the average age of all those vulnerabilities is 2.8 years old. So the
Yeah.
bottom line here is that teams are just not doing a good job fixing the most critical vulnerabilities. So teams need to leverage what they can to prioritize the fixing. So they need to leverage the CVSS scoring system, the kind of common vulnerability scoring system. They need to determine exploitability and the real world risk associated with those vulnerabilities. So doing things like checking exploit DB or attack or other feeds, looking at the EPSS or the exploit prediction scoring system, using SCA tools to aggregate all of this data and get it in one space. Teams need to evaluate if their application is actually using the dependency that has a vulnerability, right? Because this is going to help them prioritize. They need to evaluate business impact. So is it required to patch a specific vulnerability to align with GDPR or PCI DSS regulation? Is there a sensitive data impact? Or so, for example, a vulnerability in a healthcare system is a high priority. A vulnerability in an internal non-network connected dashboard is low.
Right.
Finally, consider the availability of a fix. So if a patch is available, it should be applied as soon as possible, immediately.
Right.
Otherwise, teams should look for other mitigations, like maybe firewall, web application firewall rules, putting those in place, determining if you can replace the package entirely based on maintenance record. So just visibility, prioritizing, and fixing what you can when you can.
Okay. So, Mike, also speaking about the outdated components, as per the report, 91% of code bases contain components more than 10 versions behind. So, why do you think so many projects struggle with keeping dependencies current, and what best practices can developers follow to ensure timely updates without breaking dependencies?
Sure. So I would say first thing is to keep in mind is that visibility aspect that I mentioned in answering your last question. I can't stress that enough. After that, some basic best practices again is remember semantic versioning best practices. So think about version numbering. It goes major dot minor dot patch. So if it's 1.2.3, the major is the 1, the minor is the 2, and 3 is the patch. So if there's a patch update, it's safe. It's just addressing bug fixes. If there's a minor update, then there are new features, but this usually means that the new version is backwards compatible. And then 3, for major updates, this is where you have to worry about breaking changes so that when you do update, you do the right amount of diligence and testing. What you could also do is you can actually put in version constraints to lock dependency updates to safe ranges, right? So you say, I'll allow updates, automatic updates on minor versions and the patching fixes, right? That way you can allow automation to help you stay ahead of new versions coming out and not being one of those code bases that we analyze that have all of these outdated components. So use lock files to your advantage.
Right.
When you're updating, make sure you're testing updates in a staging environment first. So have a separate branch for updates, run unit tests, run integrations tests, run end-to-end tests, and of course deploy to staging before you actually send it off to production. Sort of that CrowdStrike example that I referenced earlier. Avoid. Check change logs, right? Before you update, check the change log, which is going to avoid surprises from any breaking API changes. Of course, you can plan your updates based on deprecated features as well. And finally, schedule regular dependency reviews. This has to happen on a regular cadence. Monthly or quarterly updates should happen for non-critical dependencies. And then there should always be immediate updates to dependencies that have vulnerabilities. Those are all going to be best practices.
Okay, that makes sense. So, the another interesting point from the report is the growing adoptions of SBOMs. So, how do SBOMs help developers track track and manage security risks in the projects? So, what do you think about it?
So, the candid answer is going to be SBOMs are not for developers. They're not for development teams. They're not even for the organization building software, but they are by those organizations. So, SBOMs, as we know, they're going to provide the most amount of value to the software consumer and the operators of software, because they're used as a tool to identify existing and future risk. So
Right.
software producers are using SBOMs to provide transparency to their consumers,
Mhm.
but development teams do play a vital role in SBOM generation, right? So they have to be responsible for integrating tools that generate SBOMs at a regular cadence to accurately reflect application dependencies, every
Right.
version that's built and released. So, as we know, complete and accurate SBOMs, they are becoming increasingly more important as time goes on. In different industries, different jurisdictional regulations. To provide a couple examples, the U.S. government, if any
Mhm.
software is expected to be used by the U.S. federal government, an SBOM has to be included if it's sold to certain agencies. Healthcare and medical devices, right? The FDA is requiring SBOMs, and they're actually defining which fields have to be in those software bills and materials. Financial services, so fintech, they have to document any third-party libraries that they're using in payment processing systems. Automotive, so car manufacturers, they have to track components in their infotainment systems.
Right.
Finally, what's really starting to make is the EU Cyber Resilience Act.
Mhm.
Manufacturers, if they want to sell software to any consumer or operator in the European Union, they're
Mhm.
required to compile a software bill of materials for their projects. And there's also vulnerability requirements, vulnerability disclosure, vulnerability patching requirements in the CRA that also make SBOMs very vital. So, again, end of the day, SBOMs aren't for development teams, but development teams are the first and last stop for generating these accurate complete SBOMs.
Right. So, finally, security testing remains crucial, right? The report highlights the need for static and dynamic application security testing. So, for developers who may not be deeply involved in security, how can they integrate these testing methods into their workflows? What do you
Yeah,
think?
that's a fantastic question, right? Because we want to look at it from a solution approach.
Mhm.
Just individual point solutions, individual point products, they're no longer desired by these teams. There's too many products. Teams are looking to consolidate. So how can you take sort of a solution type approach? Now, if we're talking from a development aspect, let's break it down in those terms. Starting with early development, shifting everything as far left as possible so
Right.
that any issues can be caught when they're cheap and easy to fix. Well, you
Right.
can use software composition analysis to prevent bad dependencies from ever entering the software development lifecycle. You can use static analysis to scan for weaknesses before they're committed to an SEM or even built. And this can all be done inside an IDE. So
Right.
inside IntelliJ, inside Visual Studio, inside Eclipse. Now, if you move forward a little bit in the software development lifecycle to the code review and the build stage, you can use SCA and SAST here as well, right? You can actually run scans within the CI/CD pipeline, so integrating with tools like Jenkins and Travis CI, integrating with source code management tools like GitHub and GitLab. And what you could do is, based on the findings, you can actually fail or break builds so that these issues don't go any further into the life cycle, and automatic workflows can be put in place and triggered based on those findings. Move forward again into testing and staging. Now we start to talk about dynamic application security testing, or DAS. So you can use DAS scans to detect real world vulnerabilities in a running application. So this is sort of the hacker view of an application. You can poke and prod at an application, and you can actually do it in a production safe manner so that you're not breaking things. So, for example, a misconfigured authentication mechanism might allow unauthorized users, which a DAS tool can detect. And then finally, when these applications are in production, SCA can still be used to monitor for newly disclosed vulnerabilities. Um,
Mhm.
just because there's no vulnerability when you enabled the component doesn't mean there won't be one later. DAS tools, you can use those to simulate attacks against live applications to
Mhm.
detect runtime issues. And then you can actually use static application security testing to confirm any issues that you find. So, as an example workflow, SCA alerts a security team to a new vulnerability. You can apply a patch. You can use static analysis to confirm that you fixed that code with the patch. And then DAST is going to validate runtime security. So that's sort of the end-to-end software development lifecycle using those three big, right? We actually call those, those are the three main components and solutions we position here at Black Duck is SCA, SAST, and DAST, the big three.
Okay. Great insights, Mike. That brings us to the end. Before we wrap up, do you have any final thoughts for developers navigating open source security in 2025?
My parting thoughts would be that my empathy goes with development teams. There's been a big shift left push in the application security space. The reason for that being that's when it's easiest and cheapest, and it uses less resources to address issues. My opinion would be not to shift left, but to expand left. We can't be putting everything on development teams. We can't be dropping security tools into the laps of development teams and expecting them to be productive with them when at the end of the day, their job is to produce high quality software in increasingly tight timelines. So with the increased reliance on open source, I can understand how that makes it a lot harder for development teams, security teams, and risk management teams. So I have to recommend automation wherever possible to get in front of these issues before they spin out of control and turn into tech debt. Other than that, I think those are my only parting thoughts.
Thanks again, Mike, for sharing your expertise. And thank you to our listeners for tuning in.
Thank you.